Hello, let's do our last video, which we look at dissociation reactions and ionic equations. We revisit ionic equations and we go into a little bit more detail. So a dissociation reaction is actually the opposite of a precipitation reaction. Remember a precipitation reaction? We mixed two solutions together. Each solution was actually a positive and negative ion floating around in solution. Mixed them together, and in a precipitation reaction, one of the positive ions and one of the negative ions go together to form a precipitant. Okay, and we learned how to write the full equation for that and the ionic equation for that. Well, a dissociation reaction is the opposite. It's when you have an ionic solid and you dissolve it in water and it's soluble, and so it becomes the ions that make up the solid. And we can show that. And this is an example. So when you just take a tablespoon of salt, for example, and you stir it into some water, you end up with a solution where there's sodium ions and chloride ions in solution, and the AQ is there, so we don't have to write H2O above the arrow there. And that's pretty straightforward. This one's a little bit trickier in that a couple of things you look out for. Now this is of course copper 2 nitrate. Now how did I know it was copper 2? Well, I looked up on my information sheet nitrate, and I saw that that was -1. There's two of them, so over all the minus charges is -2. There's only one copper, so it must be copper 2+. Now, so when that dissociates, the copper is pretty straightforward. There it is, copper, and we just write the AQ. And the nitrate is a little bit trickier because we've taken this 2, tells us there's 2 nitrates, and we've had to put it in front of the nitrate. So we have 2 nitrates floating around in solution, which is very different from writing something like NO3 bracket 2. Okay, we wouldn't write that. The 2 is only there when we do equations and we want to multiply everything. We only use subscripts in equations. We use coefficients when we're balancing. So you just have to look out for little tricks like that to get you. Right, so ionic equations, we've also mentioned these. These are basically the nuts and bolts of what happens in the equation, getting rid of anything else that hasn't occurred. And so the ionic equation only shows those ions that have formed or changed during a chemical equation. Okay, anything that hasn't changed we refer to as spectator ions. So if they were there before the reaction and they're exactly the same after the reaction, nothing's happened to them chemically, and so they're referred to as spectator ions. If something has changed from, say, being neutral to having a charge, that's a chemical change, and therefore that has to be in the ionic equation. We'll do a couple of these to get an idea for them. Now, precipitation and neutralization reactions are often represented as ionic equations because it simplifies their writing, makes it a lot quicker. So with a little bit of practice you should get good at that. Now there are some rules, not too hard. First of all, you've got to of course write the correct chemical equation, and it's got to be balanced. So you've got to be able to write your formulas. You've got to use the solubility table to pick what substances are soluble or insoluble. You expand the equation by dissociating all the soluble things. So what that means is you break into positive and negative ions, all those things that are AQ. Okay, so anything that's AQ you break into their constituent positive and negative ions, and that shows the free ions that are there in solution ready to form something. You need to check acids and bases because they're a little bit tricky, but generally we don't introduce those in physical science. Basically the acids would free up hydrogens. The bases we pretty much treat as ionic substances. We cancel anything that's the same on both sides of the equation. So anything that's on the reactant side and anything that's on the product side that's the same, we get rid of. and then we're left with the net ionic equation. Note, the equation should also be balanced in charge as well as balanced in the number of atoms. Now the number of atoms should be okay, because if we've done the balanced chemical equation, that balancing just flows down into our ionic equation. So let's do an example. Let's mix sodium chloride and silver nitrate solutions. Now first of all, how did we make this sodium chloride solution and the silver nitrate solution? Well, we took some salt, added it to water, and so we got the solution, AQ. Now in this AQ, we recognize we've actually got sodium ions and chloride ions. In the silver nitrate solution, we recognize that we've got the silver and the nitrate. Now these two reactions are what we call dissociation reactions. They're a good example. So it's when you take a solid and you dissociate it into the ions, remembering to put the charges in and to make sure it balances. So we've got that, and so what we should have is we have NaClAQ plus AgNO3 AQ. Alright, and we can check our solubility table. We can use our little technique to work out what the precipitant might be. It could either be sodium nitrate or silver chloride. And you go to your periodic table, or not your periodic table, your information booklet, and you should find out. Now I'm just going to go one step further. You should find out that it's going to be the silver chloride that is the precipitant, and you're going to be left with a solution called sodium nitrate. Right, so that would be our full equation. Now the rules of writing the ionic equation, if you're asked to do all the steps, you start with this, and then anything that's AQ you break into the ions. So there's those ions. Let's get a different color. There's the silver ion, there's the nitrate ion. Another color. Now the solid we leave the same. It's only AQ things, aqueous, that we break into the ions. So there you go. Alright, now we look at that. We look at this and we see, are there any things the same? Let's get a nice color, green, on both sides. And you might see that the sodium ion is exactly the same on both sides. The nitrate ion is exactly the same on both sides. The chloride is an ion over this side, but it's not as an ion on this side, so it's changed. The silver ion on this side, but not an ion on this side, so that stays. And so we've recognized what are the spectators, the things that haven't changed, and these are circled by the green, and we cross those out. There's our precipitant. Yeah. So we cross out our spectators. What are we then left with? We're just left with the two ions that go to form the precipitant, and that would be our ionic equation. Now notice the charges balance. What do you mean by the charges balance? Well, here we have plus 1 plus minus 1, plus 1 plus minus 1, 0. What charge do we have here? 0. So the charges balance. And this is what we would call the ionic equation. Now the way I showed you earlier, let's get rid of all this writing, is if you as soon as you recognize what the precipitant is, you can just write the precipitant, then write the ions that go to make up the precipitant, and you should have the ionic equation. Works every time. Right, let's get rid of that. Here's another example. In this case we're reacting lead to nitrate solution and sodium iodide solution, and this is what you get. Nice precipitant, and you're actually told it's lead to iodide, that precipitant. And so there's our equation. Now if I was asked solely to write the ionic equation for this, I would recognize that there's our solid. Let's get a bit of better color. And so if I'm confident enough, I could go PbI2 solid. So there's our lead 2 iodide. Then I have to ask myself, well, what are the ions that make that? And one is going to be the lead 2 plus, it's in solution, and the iodine, which is going to be minus, and that's in solution. Alright, now have I finished? No, because it doesn't charge balance, it doesn't also balance in iodines, so I need to put a 2 there. And that's how I do it. But I'm fairly confident with what I'm doing. So if you don't feel confident, the danger is you would fall for some traps, like forgetting to write AQ, forgetting to identify which lead it is, and forgetting to put that 2 there, are all things that you could make mistakes. So what's the longhand version of it? Let's have a look. Okay, so you work out what the precipitant is, and so we've expanded this into the ions. Anything that's AQ has been expanded into the ions. And a couple of things to note: this 2 here, because that's been balanced, it translates into a 2 there and a 2 there. So we need 2 sodiums and 2 iodides to match up with this 2 here. And the same goes with this 2 here. That means that there's 2 sodiums and 2 nitrate ions in solution. Another trap for young players. And so we cross out the spectator ions, and we're just left with, there's our ionic equation. Now you'll be able to do these questions in class, and I'll be able to give you a hand doing them, and that will do. And you're also going to be doing all these questions on page 268 in your book in class. We'll be doing that in class, and then we've got 2 pracs that we have to do as well, which will hopefully reinforce the theory. So I hope you enjoyed all that and you followed most of it, and we'll see you in class. Bye.